Well, that wasn't easy. I was always fascinated with machine learning. I even tried my hand at it, but I was doing basic stuff like simple neural networks and genetic algorithms. Before this week, I had no idea about the depth of machine learning. I read about things that I couldn't have even imagined. Machine learning is so exciting for me. I really wanted to implement machine learning in some capacity in this project. Thankfully, Unity has a new package called Unity ML Agents. This package abstracts the really complicated parts of machine learning. So I decided to use this and see what I can do with it. But before that, let me explain machine learning, or more specifically, reinforcement learning. Simply, it is when we encourage good behavior and discourage bad behavior by rewarding or punishing the AI. As humans, we do this every day. We eat good food because it's rewarding and tasty, and we avoid touching hot surfaces because it hurts us. There's a lot more to reinforcement learning, but this is a simplified explanation of it. Whenever I'm trying to learn any new technology, first I watch some tutorials on it and see how things are done. And then I try to create my own small project using the technology. This makes it easier to understand concepts and also gives me some experience with it. The project I decided to make was an agent that tries to collect a coin. A machine learning agent has to have two things: actions and observations. I gave this agent four actions. The agent can move forward or backwards, and left or right. When it comes to giving observations to an agent, it is pretty open ended. For this agent, I gave it two observations: the position of itself and the position of the coin. Now comes the rewards. I obviously reward the agent for collecting the coin, but I also reward it for closing in on the coin. I also punish it for every frame that it hasn't collected the coin. This encourages the agent to move as fast as possible. I started training the agent, and I saw that after a few minutes, the agent had learned that the coin was the reward. This was so exciting to see. Even for such a simple simulation, I had a lot of trouble and I had to explore multiple machine learning topics. But when the agent was done training, it gave me the confidence that I could implement machine learning in Project Deal. And now it was finally time to do it. I was going to implement machine learning in Project Deal. I completely underestimated how tough this was going to be. I thought I'll add a couple of lines of code and I'll be done. Not really. First thing that I had to do was make the environment machine friendly. Let me explain what I mean by that. When a human plays the game, they wait to think and then make their decision. But a machine learning agent doesn't need this time. It can instantaneously make decisions. So I had to remove anything that caused delay between moves, like the animation playing or slowly flipping the tiles. Once I had the environment ready, it was time to set up the agent. Deciding the observation and actions wasn't very tough. The actions were that the agent could tap on a tile or flip the grid. The observation was the state of the board, so all the tiles in the grid and the orientation of the grid. I rewarded the agent for any tile that was in the winning position and punished it for any tile that was in the losing position. I also rewarded it when it completely solved a level. This was the wrong approach. The agent soon figured out if it could get more tiles in the winning position than in the losing position, and then not play a move, it could maximize the reward without solving the puzzle. I would be lying if I said I wasn't impressed, but this was not the desired behavior. I tried many iterations, but nothing seemed to make the agent better. I played with the reward structure, the observation, double checked the environment, but nothing seemed to work. I was about to give up when I learned about action masking. This is when I tell the machine learning agent that it can ignore all the inactive tiles. This made all the difference. I finally saw the rewards graph trend upwards. I was finally able to train an agent that could solve the puzzle. The agent by no means is perfect, but the more I train it, the better it will get. I learned so much: what hyperparameters are, how rewards should be structured, and so much more about machine learning. And thanks to some awesome people in the RTDev Discord server that helped me with this. I've always wanted to implement machine learning for real life applications. And finally, I can say I did it. So, how do I plan to use this agent in the game? I plan to use it for two things. Whenever the agent solves a level, It stores the minimum number of moves it took to solve that level. This will allow me to structure high scores and rewards for the players of the game. I was planning to have a star-based score structure that most puzzle games do. I can use the machine learning data to create that structure. I'm also going to use this agent to playtest all the levels. I effectively used machine learning to do QA for my game. This was very tough, to say the least. I was ready to give up, but I'm glad I didn't. It was incredibly rewarding. And after training the agent with some tougher levels, I was exhausted and I called it a night. Next week, I'm going to focus on UI and fixing some of the bugs that I've already found.